Thanks. Thank you, Murat. Thank you, everyone. Yeah, it's my pleasure to be here. This is the second time I'm getting in touch with Magnimind community. People still watch the first session. We actually, in Johnson Novas, we use the same YouTube video that is stole from Magnimind website, actually. So we are also using the same YouTube video on our channels, on our platforms. It was all about name identity recognition in clinical domain. So I'm myself based in Netherlands. Murat gave a short intro. Thanks again for this. So I've been here for the last 4 years, 3.5 years, and I'm working as the lead data scientist at Johnson Novas, which is the global healthcare NLP company. So today, I'm not going to talk about what Spark NLP or named identity recognition or this kind of stuff. Of course, I will do some intro about, since I work in industry with different verticals, like not just in healthcare, but today, because of short notice period, I have some slides that I will talk about the projects that we run with our top pharma companies. Because of the latest pandemic situation, you heard many of those companies before, probably, which you didn't probably heard before. All these pharma companies and healthcare IT companies that we work with. So I will try to cover what kind of problems we solve over there. And then what is the status of machine learning in industry, actually, because we know the hype and why, how we actually train and deploy the models in production. And I'll just talk a little bit about that as well. And then we will have some Q&A session. I really look forward to have that session, by the way. If you have some specific questions to answer, like how life goes during the POCs, like proof of concepts, projects with the customers, or how do I do, or how do I solve certain problems in healthcare domain by using machine learning or computer vision or just NLP. Okay, so I'm just going to share my screen at first. I hope you guys enjoy. Let me share my screen. Please let me know if you guys. Yeah, I think you all see my screen, right? So I will start with. So if you are not able to see my screen, please let me know. But Murat, it looks like we are okay, right, from your side?
Yeah, it's good. Yeah.
Okay, perfect. So so actually, right now, if we want to talk about the machine learning in industry, people call it AI, right? So AI is actually machine learning is the roof concept. On top of that, of course, we call it data science, but data science is a collection of the tools that we implement all these algorithms and the networks, actually. But machine learning is the umbrella term that has, actually, AI is the umbrella term. Machine learning is just one part of how we do AI. Okay, because under AI, we also have some heuristics, we also have some simulations, we also have some optimizations and some or genetic algorithms or so many other stuff that has been shaking the industry for 1950s, actually. So, but machine learning for the with the latest development in hardware acceleration, algorithms, availability of the data, and computation platforms, and on top of that, easy to use libraries, thanks to Python and its a huge community, easy to use libraries like Keras, TensorFlow, PyTorch, sklearn, Pandas, these kind of libraries all made this hype available for the last 10 years, let's say. Right now, in classical software development cycle, we call it software 1.0, right? So we try to accomplish some goal. Let's say we want to automate some process in our business flow. So we try to code this up to end up with this goal. In machine learning, we try to let the machine learn this process by giving the input and an output. That's why right now it's another paradigm in software development. But people usually, the hype was really good, everyone jump into this domain and then try to build some cool models, computer vision, NLP, reinforcement learning, robotics, some AlphaGo, OpenAI, etc. Right, driverless cars technology, etc. But right now, people became more reliant on machine learning right now in their workflow. But sadly, like just like more than 80% of all these projects are still POC, which means that still not in production level. So everyone tries to understand how they can leverage machine learning and AI into their domain so that they can optimize their processes, gain more money, right? Earn more money with less effort and with less human, with less error. Because if you spend less time on doing some manual task, or if you hire less people to do some repetitive task, which is kind of boring and hard to find those people, or usually low skill people. So that's why all the industries in every domain, like the pharmaceutical, defense, energy industry, education industry, every industry you can count here, try to integrate ML somehow into their workflow. But when it comes to deployment, as I said, like more than 80% of the projects are still under POC level. And some people say that 80% or 85% of the projects, machine learning projects, fails before ending up in the production. So everything starts with that hidden technical debt in machine learning. Like technical debt term, you can understand from Chernobyl event actually. Like when you try to avoid some cost, some procedures, that will end. You will probably end up with a huge technical debt at the end of the day, right? You might be able to enjoy some, low cost at the beginning because crash doesn't happen at one day, right? So it's the culmination of multiple errors happens. So right now we see in industry that people are trying to rely on machine learning more and more, but then they forget that this is a whole infrastructure. This is not just machine learning. As you can see on this, this is the representation of the ML ops actually. So ML ops concept is the DevOps of machine learning. We can call it how to productionize all these machine learning models in industry, because the goal here is to get benefit, to use this everywhere that we use in our cell phone. Right now, everything that we use is powered by machine learning. But given that this is just the 10% of the machine learning algorithms or machine learning products out there, we are still getting huge benefit from that, right? So which means that if you could be able to leverage the rest of the failing ones, if you can make them successful and then successfully implement into workflow by integrating all the other IT infrastructure, we cannot imagine what could happen actually, how our life would evolve. So in this slide, I wanted to explain more about machine learning is not just there to cover the entire scope. No, it's just one single tiny process. Actually, it's the heart. Of course, when you think about a movement, like the heart or brain is just 1% of the body maybe, but machine learning is the machine learning code and algorithm that black box, right, is the one that needs all the other boxes, all the other services that needs to be served into your workflow. That's why MLOps concept is getting much traction lately, because if you cannot actively retrain your models, automate your data ingestion pipeline, and then deployment process, and then serve successfully on a scale with your customers, you will definitely have an issue at the end of the day, and then you will probably get not benefit at all. So that's why we try to be aware of the hidden technical depth of learning. That's why when you want to work like the industries, you usually try to outsource. Okay, so like especially in the healthcare domain, I was kind of curious about why those big companies are outsourcing their projects, right? Because this is a highly specific domain that might require some specific skill set that you need to borrow from healthcare domain, machine learning domain, computer science domain, biomedical domain, industry, etc. So this is not just happening for healthcare, for all the other industries like energy or defense, because you need the domain expert at first, and then you need the machine learning and the data science experts to, and then if you can find some unicorn to handle all this, right? Of course, it's a dream, but you usually try to understand how things works in that domain before starting to implement. So outsourcing these kind of projects are highly normal, by the way, in industry. Even you would be a Google or Facebook or big pharma companies like Roche, Novartis, or big hospital chains like Mount Sinai or Kaiser Permanente, right? You these companies still outsource some of their in-house ideas, some of their POCs to companies like Johnson Labs or some other healthcare analytic companies. We are one of those companies that that run these kind of projects with them, because right now, in terms of NLP, we call that like less than 50% of the structured data, like tabular data that we use at that Kaggle data set, that all the websites, right? So we like even the structured data we get to use just 50. We get the benefits from 50% of them. And for the unstructured data, which is the reality of the life that we are living in, right? Less than 1% is established. Especially in the healthcare domain, there's a huge jam of information sitting there, and it's hard to extract those jam and then feed it into the workflow or feed your machine learning models. So this is highly domain specific field. So I'm just talking about healthcare right now, but you can just reflect everything that I said into other domains that I'm not going to mention today. Okay, because every domain has its own language, probably, or its own trends that you might miss if you don't have any experience. That's why we suggest young people who wants to like some enthusiasts to, if they want to jump into data science, we always try to suggest like, guys, try to be like a T-shape, like try to learn as much as you can, but specialize on one topic so that you can jump into any other topic and then focus more. But since the limit is the sky, right? There are too many things to under the sun that you need to learn if you want to get master, right? But that's why in healthcare domain, especially in healthcare domain, even the human being who is working in that domain is having a hard time understanding the language being spoken. Natural language understanding is already a hard problem, actually. And when you try to predict something in that jungle, it's another huge deal that you will try to hit the wall again and again, by the way, if you don't have a clear picture in your mind. So because human language itself is nuanced, fuzzy, contextual, like the same sentence would mean something else, right? Given the context, or due to the fast pace in the healthcare domain, like you see from the movies or the TV shows, right? All the doctors and the clinical like care providers, they usually rush because of the sensitivity of the issues at the hospitals or the healthcare industries, right? So, and the physicians sadly spend most of their time for record keeping, like a patient-doctor conversation, nurse-doctor conversations, or recording what is prescribed to patient and when, or recording the patient histories. So, which means that if the goal of machine learning here in healthcare industry, in terms of NLP, we can say that try to reduce this load by automating some stuff rather than try to predict. If we can automate some stuff, we can let doctors and physicians spend more time with the patients, right? So let's talk about how we solve problems in the healthcare domain. So every project that we run, at the end of this slice, by the way, like half of this slice will be case studies, which I'm going to skip the first part a little bit faster because I'm just going to cover the main pillars of NLP in healthcare. And then I'm going to cover the case studies that we run with the other companies so that you can get to see what kind of problems we try to solve in industry. So everything starts with name data recognition in an NLP when it comes to healthcare, because we try to get the most meaningful chunk of that nonsense text out there, which is highly underutilized actually. So if you get to extract the, let's say, medication information or oncological entities, then you can use this entity to fit the other components into your pipeline. So let's say that you want to find the oncological entities, and then find some terminologies. We call it like there are different terminologies in healthcare domain, like ICD-10, CPT, SNOMED, etc. Which means that you need to fit this to the do that model. We call it entity linking, entity resolution, and then we are using all these like a bird, sentence bird, or some hierarchical machine learning stuff, etc. To connect the dots to get the to feed the unstructured nonsense data, and at the end of the day we want to have some some graph to that would make sense in your mind, right, when you look at that one. Because as a human, when you read that text, you kind of understand what it means, because you somehow connect the dots in your brain, which is you evolved so far. But when it comes to machine learning, it needs to learn how to connect the dots, right? So, and then you want, for example, you may want to, like another use case would be the identification, like removing the sensitive information from the clinical documents. If you are going to process this document with some other stakeholders, if you want to share this data, with sensitive data with some other people or some other hospitals, right? In that case, you want to de-identify, remove the sensitive information, or if you want to share the data set with some research community, you don't want that sensitive information disclosed, right? So that's why we connect. So we have some certain softwares at Johnson Labs that we developed, that which I'm not going to cover, but you can just Google it, like Spark NLP, which like most of my talks revolve around Spark NLP, by the way, for the last few years. So we try to accomplish these tasks under one single library, one single software that people do not need to have, even do not even need to have a internet connection at all, like even the translation or language detection. So what we are trying to do, as I told, I'm going to cover healthcare industry. So the goal is to make predictions or automate some manual process, using electronic health records or text data, which is generated through these kind of interactions, like patient, doctor, or some procedures, some visits, right? So there are tons of document generated during these visits. So we try to, like, at first at the end of, like, we start with this unstructured text documents. It might be PDF, it might be images, it might be x-rays, right? Because even the x-rays have some text data, like name or some specific information or ID that needs to be identified or obfuscate. Obfuscate means replacing the sensitive information with fake entities, so that the integrity of the document would be preserved while not disclosing the sensitive information. Okay, so we like the machine learning algorithms, right? Like most of us in this talk are, probably practitioners in this domain, in machine learning. So the goal is to end up with some tabular data, some scalar features that we can use to feed to our networks, to our machine learning models, right? Like by some representation of the entire features that we have. We will probably create some features on the fly due to feature engineering steps, and then we might need to vectorize our text data to be able to feed to our networks or algorithms. So in this case, let's call it FIRST. So it's another format that the healthcare information is stored in some different formats in let's say tabular way. Then you may want to use this on a timeline, because we are trying to draw the picture, like create the longitudinal view of a patient journey, which means that when this patient hospitalized, diagnosed certain condition, and then prescribe medicine A, B, C, and then discharge, and then have another issue later on, and then readmitted to the hospital, some family issues, etc. Which means that one patient has a long history in the past and during these visits, which means that by using the bits and bolts that we collected at the top and the second row, we try to put this clinical events in a timeline to make sense out of that. Then we would be able to answer those kind of questions, like what about the patient's current state needs to be known? What parts of the patient's past history should be reviewed? Or what kind of medication will be applied to this patient? Or if patient has a metastasis on his liver, when does this metastasis will jump to liver, right? So because if we can put all these events on a timeline, then we can use machine learning to predict the next step, like in a timeline, if you think of this as a time series problem. Or if there is a pattern as a human, as a physician, you might skip, because you probably heard some news on LinkedIn or some other blog posts or some articles or popular websites that machine learning or deep learning architectures are very good at extracting some patterns that as a human we fail to understand. Of course, of course it's also dumb, right? Because maybe the models are stuck on something and then stuck on like learned. Let's say that you want to predict if this is a cat or dog, or right. If you use always the same background for the cats and another background for the dogs, maybe the model learns from the background, not the cat and dogs pictures, right? So that's the curse of deep learning, actually. So, but sometimes we use deep learning, especially deep learning, because the highly parameterized networks, deep learning, when I say, is very good at extracting some patterns as a human we fail to understand. So that's why we sometimes try to use deep learning architectures to extract some knowledge that we usually do not know, or against the science. Actually, sometimes we end up with some conclusion or some observation during training our models. While the models are being learned, we also learn as a human, by the way. Like we also learn while training the models as a human, means like as a data scientist, we also learn during that process. We also end up with some, like we observe something that is very surprising, and that would be highly useful to explain something else that we couldn't solve before. Okay, so every day, like this is the joy of working in this domain. Actually, every day you learn something new, and then you explore, and then there's a huge opportunity to create something new that haven't been experienced before. So let's say that we want to solve, like we want to predict if a patient would develop a metastasis on certain sites. Okay, so let's say that there's a lung cancer patient who is visiting the clinics for the last 5 years, which means that there are probably more than 1,000 documents generated so far for this specific patient. And in this patient, let's say that now in stage 4 has some metastasis, and then metastasis is spreading around the body. Okay, so let's say that there's a stage 4 adenocarcinoma on the lungs. Now it's going to skip to, like it's going to jump to bones, and then the brains, and then the cervical systems, etc. So which means that if you have enough data samples, if you enough patients following some patterns, you might want to know if a patient would develop a metastasis on certain sites at certain period of time, given time windows, right? In that case, that would be highly interesting to put all the facts during these visits, and then try to understand what makes that pattern, right? What happens to this patient between the date of A and B, and then this patient would develop a metastasis on certain sites. So like a classical approach would be extracting all these text features, and then using the NLP, extracting all these name identities, relations, entity codes, assertion status like negativity scope, etc., or some laboratory test or some past history, like a father with lung cancer history, right? This kind of family factors, or some other scalar features that are collected during some laboratory tests. If you merge all this information, which is the main goal of NLP, by the way, because usually scalar features are there, but the text data is usually skipped. So if you also extract the features from the text data and then merge all and then build your model, you will probably have a good understanding of what's going on with this patient and what makes like if there's a specific pattern between the metastatic sites. If you can find this, you can apply the same to other patient and then try to intervene before that event happens. That's why we try to predict the future, right, with machine learning. So we, as I said, putting the clinical facts on a timeline is a major problem in healthcare industry, which is usually misunderstood or understudied, actually. So and you cannot just do this with the conventional ways or some automation tools. You can just record everything at every visit by using some software systems that you already integrated into your framework, right? But when it comes to some verbal communications, some text data, it's hard to put this into timeline. That's why if you manage to build such a timeline, you could be able to understand the patterns that were not visible. Actually, I want to share some story by coming back. So in here, for example, we are talking about the AI in industry, right? Let's talk about, because I'm not a physician, but when I first started to work on this project, this is an actual project, by the way. I just disclosed I just hide the name of the customers, of course, and the details. But I just want to explain how I ended up such a way of solving this problem, right? So let's say that, I thought that at first. By the way, if you don't know that domain, if you are not working, that's because I'm not a physician. Even if I would be a physician, I didn't work in I probably didn't work in oncology, right? So, which means that you at first need to read some relevant researchers, even the blog posts. This is what I did at first. I read what's going on. So I wanted to understand how this metastasis develop, because there might be some features that I might skip if I don't understand this problem. Actually, during my PhD, for example, we are trying to predict if a certain disease is on a plant leaves, okay, would skip from one plant to another, like a tomato, potato leaves, some agricultural application of computer vision. It's weird that I'm working in computer vision in my PhD and in my academic research, but in industry, I'm working with NLP. But the foundations are same, right? So in that case, for example, we were trying to understand what makes this specific plant have that specific disease that that is causing the other plants plucked, get the same disease, or how to find these anomalies before it's spread around the entire field, right? It's like an outlier detection. So in that case, if you just at first I was struggling at something from my side, because I'm not an agricultural as well. So I didn't work in this domain before, which means that I had to learn something that how diseases are detected by experts. Is it color? Is it texture of the leaf? Is it like some atmospheric conditions, right? I don't know. Or if they just feel it when they look at you develop some sense by working on the same subjects again and again, which you cannot verbally explain, but you somehow understand, right? So if I didn't read anything at all about how these diseases develop on that plants, I wouldn't be able to build any model that could find the pattern, because you need to help the model understand, build the model. So feature engineering step is a crucial step here. Even of course, in deep learning, if you are working with the computer vision or in image data set, you usually do not need to worry about the feature engineering step. You just let the models, because it's deep learning. So it somehow learns that features that you wouldn't be able to manually craft, right? But when it comes to NLP, you need to create those features, because these are all disparate, like a separate distributed data all over the hospitals, all over the history, right? And then you need to help the model connect to us, because otherwise, no human being, even the human being, may not be able to connect the dots if they don't see the entire picture, because you cannot look at multiple things, like more than 4 or 5 things at the same time, right? Try to track like five targets at the same time. So anyway, in that case, what I did is I read a bunch of articles which are written by the physicians and then the data scientists and then the researchers, right? And then my common sense. So I thought that, okay, if that patient has a 5 years of history and 1,000 documents talking about specific period of his life during that diagnosis, let's say lung cancer. So if that patient in the next week at some time develop a metastasis on his brain, which means that for the next visits, mentioning of brain related entities or tests or procedures should be higher than the other sites, right? So which means that they're from like during the next visit, probably the doctors will focus more on the issues related to brain and lung, or the relationship between these two, or the test will be applied around these sites, organs, let's say. Which means that if you check the X-rays, CT scans, or some lab tests, and then try to extract the entities from these reports, you will probably see that the mentioning of these sites will be higher than the other sites, which kind of give us some intuition that even I just jump into the cycle and then I try to find out if this patient, what does this patient has by just checking the reports for a few weeks without looking the back and then the future. I would probably understand that, okay, this patient for the last few weeks, the doctors, the physicians, everything is revolved around certain entities, certain sites, certain body parts, certain medical diagnosis, which means that machine can learn from this as well. So what I did is I tried to extract all these entities from this documents and then put them on a timeline and then try to chart them to see that if the population of if the mentioning of the certain entities get high, like peak during some time period. So for example, January patient has no issue with the brain metastasis or brain related symptoms. And then February, March, and then March, he started to see some symptoms related to brain, like some nervous systems, etc. And then April and May, and then there are some tests applied on like a central nervous system or brain related, which means that the mentioning of these entities will be highly populated in the records. So by just counting the frequencies by the positive mentioning, not the negative, like, because it might say that there is no metastasis. So no metastasis means that there's an absent assertion over there. So in that case, you will probably need to skip that. You shouldn't include that in the future. That's why by using your knowledge, your common sense as a human, how you see the things, right? We inject something into this process that we build our models. Then, okay, no need to build a timeline actually. So what if I just count the number of the occurrences of certain entities on certain point of the time, and then if I set a threshold, I might be able to find if that patient develop a metastasis from brain to lung to brain, etc. So that's kind of intuitions that you develop while working on the same problem again and again. So for example, as a physician, when you read one paragraph of text, okay, so our goal as data scientists to make this one short paragraph as understandable as possible by the rest of the modules in our software stack, right? Because as a human, when you read that just one sentence, you like many bulbs like in your mind, right? You just somehow connect the dots. You build these kind of graphs in your mind, or at the end of the day, you want to have something like this, because if there's a symptom and then on certain side of the body with some measurement, right? And there are some tests applied for this issue. Now you want to know which body part is impacted or which test is applied on which body part, right? So that you can convert this text into tabular format. Then you would be able to query that in a conventional way, right? Like instead of trying to use some highly sophisticated text to SQL algorithms, you may want to query this in a conventional way that you extract certain data points from your structured data set. So anyway, the goal is feeding this text and then end up with such a graph so that everything is connected to each other. Like a CT scan is applied because of hematoma, and the CPT code of CT scan is 1, 2, 3, 4. Why do we worry about the codes? The codes are the formalized way of these procedures or these tests and then the disorders, so that hospitals use these tests for record keeping, for the insurance purposes, for the reimbursements, right? So that they get the right amount of money for the test applied. Okay, so or they can detect the fraud actually if that test shouldn't be applied, blah blah. So they should be able to understand this. And which body? Abdomen body part. So the CT scan is applied on the abdomen, on the left side of the abdomen, which means that if you can build an NLP pipeline or a machine learning pipeline to connect all these dots, extract all these data points, and then connect the dots, then so that you can just offload this data, this tabular data from now on. It's right now granular, right? You can just store all this information into certain cells and tables. So, and then you can, like, let's say that you wrote some API, right? You wrote an API, and then the physicians just feed their text, and then you end up with some JSON files that you can populate other tables, or just present these entities, these predictions on certain cells on your UI, right? Maybe you have some dashboard that you want to visualize after every tomography, right? After each tomography, physicians write some notes, radiologists. So your goal would be able to like present these findings to decision makers, let's say. So in that case, you may want to, your pipeline is to extract this kind of JSON that could be digestible by the rest of the process or the front ends, right? So that's what we do. Like that is the end goal. So like I'm talking about clinical and named entity recognition here, but let's say what we are, why we are using machine learning anyway, right? So in NLP, by the way, like why we are using NLP in healthcare to solve certain problems. Maybe we are like the first, of course, extract structured data from text. Second, automate record keeping. I value this process a lot, by the way. Automate record keeping and abstraction process is the most viable and valuable actually way of doing like applying machine learning in any industry, because you may not be able to build a highly confident, highly accurate prediction systems, because time will drift, everything will change, your models will drift in the future, and then will lose its power when the data points change if you don't update it, and that there will be some glitches in your infra that you may not be able to get some predictions, or the model trained on one domain, one distribution will not be able to do well on the other domains or other distribution. For example, we get these questions a lot from our customers while working with the other people. So they just wanted to use some pre-trained models at first, because labeling is hard, right? If you are not using self-supervised or weakly supervised or semi-supervised methods. So like we usually say that instead of trying to figure out which unsupervised method to use, just sit down for a few weeks and annotate your own data, which is going to be, because you need some label to let the model learn faster than it can learn from others, even from reinforcement. Anyway, so because it needs some signal to learn. So that signal would come from human mind by labeling, so which is going to be more successful than learning from some other weak signals. Anyway, so, but prediction is a hard problem. As I said, the one model trained on one distribution will probably fail on the other distribution if you are not going to represent or weight these data points given the domain. So that's why automating record keeping and abstraction process is the most viable option that the machine learning models could play role in industry actually. Even if the prediction fails, because it's debatable actually, because even if successful, people will question if it's explainable, especially in the sensitive domains like healthcare or finance, right? They will always try to say, okay, why this decision, why this prediction is done, right? So the reasons behind this prediction, if you are using deep learning or some non-parametric models, which is going to be really hard to explain. Of course, there are some Eli 5, Sharp, these kind of tools developed for the last few years to explain. Yeah, it's another research area, by the way, explainable AI. But it's usually hard to convince the decision makers when it comes to end up with some weird predictions. And another curse of deep learning models is that deep learning models like these networks are highly confident even they are wrong. Because as a human, when you say that this is not cat, yeah, even if you are confused, you in your mind you kind of say, okay, this looks like a cat, but this could be a duck, but this is duck, etc. Right? So you have some uncertainty in your mind that you assign. You say that, okay, I'm not sure, but this looks like a cat. And you say that, okay, 55, 56. Or of course, you don't give this kind of granular predictions, of course, while talking to your friend. You have some uncertainty in your mind. But when it comes to, due to the design principles, if you are not, normalizing the output, like if it's multi-classification problem, we are using softmax, and then the softmax usually favors the majority class, etc. If this is an imbalance data set. Anyway, for example, that anomaly detection, let's say that we are trying to detect some anomalies. So since the model learned from the majority, it will probably assign more, even it says that this is not an anomaly, it will probably say, even if it's a false positive, the confidence scores in the output of the network will probably be high. So because people tend to use the softmax output as a way of confidence, which may not be correct at the like most of the time. Anyway, what I want to say that in short, automate the record keeping process or abstraction process is the most viable option that you can integrate machine learning into your workflows. Which is the chance, like the success rate is high given the prediction models. Or you may want to use these features to feed your downstream task. Like as I explained in the metastasis project, right? You create some features and then feed into your machine learning models. So these features comes from other machine learning models, right? Or some other algorithms need some entities. Let's say, for example, on here, entity linking needs NERs. So NERs comes from this algorithm. So which means that you may want to feed your downstream text with the other machine learning models. So we like on the left hand side, you can see this kind of charts in every domain, by the way, because by using machine learning, like NLP is just part of machine learning, right? So let's say that you want to predict something in finance. So we apply machine learning to help decision makers, right? To make some decisions faster and better, or as I said, automating some processes. So we try to let the model understand the things that as human we understand, right? So let me summarize what I try to understand here. We start with one text in NLP in healthcare, and then we extract the entities, as you can see on this slide. And the next step is usually try to find which of these entities are irrelevant to my use case, or maybe there's a lung cancer, mentioning lung cancer, but if I use the lung cancer as a feature, right? I might, and I skip that it's not related to patient, but it's related to family member. I might have a big mistake, because if you use the lung cancer as a feature in your prediction model, let's say metastasis prediction, you fail because it's not related to patient itself, but the mother. But if you somehow inject this information with this assertion status, right in the same network, which means that there is a lung cancer mentioning, but it's not related to patient, but it's mother. Even it's mother or father, this is also important feature, right? So that's why we need to use this kind of negativity scope detection to filter out the irrelevant. This is highly useful for the clinical trials, by the way, which I'm going to cover, by the way. Clinical trials, you usually have some inclusion and exclusion criteria that you invite some patients, your clinical trials, to test. But let's say that you want to test some test success of some vaccine for the COVID patients, right? So you invite some patient who already got the first dose, let's say, and then also have some respiratory disorders in his family, blah, blah. So you have some inclusion criteria, you also have some exclusion criteria. You say that, okay, that patient shouldn't have gotten the second dose. That patient shouldn't contract the virus for the last 6 months, blah, blah, right? So with this kind of exclusion criteria, you find some patient cohort to invite to your trials. So if you just rely on the text, if you just rely on the tabular data, you will probably fail to invite the relevant patients. And then because there are some hidden gem in the text data, like mother with lung cancer, right? Which probably not tabulated. And then when you query that data sets for the patient, you probably invite irrelevant or outdated patients to your clinical trials. That's why you need to offload the data from your stink text data as well, and then tabularize so that you can apply the inclusion or exclusion criteria precisely. Then you want to connect the dots. You want to find out which entities are related to which one, and then that's why you need to do relation extraction. As a human, when you read the one text, you kind of connect, right? So you know that if it's of course confusing sometimes, like some genders, like some due to the nature of the language being used, you may also be confused if it's talking about the patient itself or his father or his mother, or talking about specific test, etc. Anyway, by using this kind of algorithms, we are trying to connect the dots so that we don't link the we don't need the, let's say, one body part with another body part, even if it's that body part is not mentioned in that test. Then we want to extract the terminologies for that, reporting purposes, reimbursement purposes, normalizing purposes, right? Or assigning some risk criteria. That's why you need all these features, and the identification. As I explained, you may want to disclose or like hide, mask some sensitive information before disclosing with the other people, right? Because you may want to share this information with the other stakeholders, or even with the other people in the analytics team, because they may not have the right credentials to access the data, like sensitive data. Then either you mask or replace with the or obfuscate, like replace with the fake entities. So usually when we work with the projects, usually the data is not in that clear format, right? It's usually image, especially in the healthcare domain, or PDFs, like a 5 years old PDF documents or some facts. Actually, in the healthcare domain, it's very usual that the records are like exchanged through fax, which for the last 5 years, I guess, the like healthcare industry digitized. But before that, the fax were the main way of communicating, exchange the records between the hospitals and then the departments, even the floors in the hospitals, right? So, right now in the machine learning era, we want to leverage this data, right? So the source of the data is right now hard copy. And then the hard copy is usually like we scan it, and then right now we have the PDF or image. So, and if you wanna go back and then use all these text data, you usually need some optical character recognition or computer vision models to understand what's going on in that text, in that document, so that you offload the text, you apply some image processing to make the text readable. So that's what like a Tesseract, right? This kind of open source or Spark OCR, which is licensed, by the way, is doing, like extracting the text in a most clear and understandable way to feed to NLP pipeline. So far, like we were thinking about OCR just for the text, but for the last few years, there's a multimodal algorithms developed to understand the text, like a document itself, right? Because if you just extract the text, you kind of get the sense, of course. But as a human, if I ask you what kind of form is this, by just looking at, you can understand that okay, it's a pathology form or it's a radiology report if you are working in that domain, or if like this is an invoice if you are doing another, if this is another domain. This is invoice. This is email, right? Just by looking looking at some keywords or some layout information. So that's why right now we call it multimodal, which is like the combination of computer vision and NLP and some layout information are leveraged to extract certain entities, certain information from data. So we call it in Spark NLP as like visual document classifier or visual document NER. Instead of trying to get the text and then build some NLP models, if you use the layout information as well, you get more information to help the model understand why this value is linked to this key, right? So, or you have some tables on PDFs or images that you want to extract, like some tabular data that you want to convert to tables, right? So, which is table extraction algorithms are being developed. So, or you are going to extract some handwritten information. Maybe you just don't want to know that if this form is signed or not. In that case, you may need, again, computer vision and NLP combination and OCR, like combination of everything to understand what's going on. So you at first want to know if there's a signature on this form. So your object detection algorithm can detect the signature at first, and then you can send this area, that like crop this area, and then send to handwritten recognition algorithm, and it will try to understand what's written over there. Right. So in our projects, for example, if you are working with this kind of handwritten text, we usually apply object detection to find which strain on this kind of data set, by the way, to find if it's a signature, if it's a date, if it's a name, etc. Right. And then try to understand what's inside, because it's a harder problem. Handwritten recognition is a very hard problem, which is usually hard when it comes to strings and the text, but it's kind of manageable when it comes to date because of the, like a scope is narrow when it comes to date. The variation is not as much as you can see in a free text handwritten, right? So that's why there are some models developed. By the way, there is no out-of-the-box solution for the handwritten recognition yet. Yeah, even the Google or some AWS cloud providers doesn't have this kind of solutions yet, which is out of the box that you can use, like you can use with the computer vision API, right? All these cloud providers already have computer vision or natural language understanding or speech recognition modules, but when it comes to handwritten recognition, this is still not a full-fledged. There is still not a full-fledged solution that you might just use as a plug-and-play solution. That's why you usually end up training your own models. So let's talk about some case studies that we run with the customers in this domain. So if we are just talking about the hospital settings, so in a hospital, if you would be working with the hospitals, like in the hospitals, so you may want to map all these diagnosis codes to the parent categories so that you can try to understand which indications appear when, right? Or maybe you are responsible for the stock of the medications on this hospital, and you would like to know, you always want to make sure that you always have enough stocks, not just for the medication, maybe some surgical equipment, etc., right? Or some equipment, test equipment like MRI devices should be fully functional at certain point of time because of the load of these kind of issues, right? Which is highly vital issues, critical issues, that you need those devices like 100% working all the time. So that's why if you can predict the load of certain events, clinical events, or if you can find the relationship between the events, you can kind of manage these kind of daily activities with more in a more predictable way, right? That's why we try to predict something, right? So if you have like on top of automation and abstraction process, if you also have a way of predicting predicting something in the future, right? So you can use machine learning to make your life easier, even in this, like in every industry you would be working in right now. So let me skip these parts because I already talked a lot. So this is how we solve certain problems in the healthcare domain, like in the hospitals, by the way. So like feeding the text and extracting all these entities and then finding their types. And then, so this is our end-to-end pipeline. So at the end of the day, we want to extract some information to store somewhere or to report somewhere. So and there are some tools that we use to accomplish this, like in NLP, we have sentence detection, tokenization, word embeddings, or some resolution, some networks to feed and then find the relationship, etc. Right? So you can create these kind of dashboards to understand what's going on in that hospital by using the sitting text data. So let me explain. Let me cover some case studies which would make much more sense in terms of what's going on in healthcare industry right now, in terms of like what they need actually, what they do, how they are claiming that they are doing state of the art machine learning in their models, because everyone claims right now state of the art, right? So let me cover like a few use cases. So I will have like 5 to 6 different use cases right now, which I'm going to cover one by one. So each one of them is run with another company that our company like Johnson has worked with before. So MCG is like one healthcare analytics company that asks us to help them how to use like how to provide an assistive intelligence in documenting evidence-based guidelines. So they have some guidelines, which is real world evidence, we call that. So how to automate that process to extract that information. It's, as I said, everything that I explained in clinical NLP so far is trying to solve these kind of problems, like how to extract this information and then build something that usually human coders or physicians accomplish manually. So iQuartic is another healthcare analytics company which is trying to assign some clinical risk factors because, as I said, as a hospital, you need to make money, right? So you have some procedures applied, you have some costs, and you have some patients coming in every day. So you would like to report, you would like to handle the finance, you would like to report all what's happened, what's applied to this patient, right? To the patient's insurance company. So you need to report something. So this is usually done by human beings which are expert in this abstraction process, like finding which procedure is applied and then which code, then reporting that code that insurance companies would like to see. Or as a hospital, you would like to send that code because its reimbursement rate is higher than the other code. So if you make a mistake and then report something wrong, you would get paid lower than what you already spent, right? But these codes is not very easy to calculate because it also depends on the age of the patient, gender of the patient, the history of the patient. So there are some risk factors that you need that needs to be calculated. So there are some guidelines for this. So which means that by using NLP and machine learning, you can calculate these risk factors, because risk factor calculation is just the equation, but that the parameters, like the variables in that equation, should come from somewhere, some automated pipelines or some human being. So if you are using machine learning, so you can extract all this information to this equation and then end up with some risk factors. So that's what we did with them. So MetaStream is another company which is trying to improve their like a code abstraction or some reporting like by using NLP. And Select Data, they are the company who are providing home health services that they apply. There are some physicians visiting the patients at their home, and then they are reporting all these treatments and the procedures to some companies, some insurance companies, as I said, and then they want to automate this process. And Roche, we all know Roche, right? So they also want to automate their abstraction process from the radiology and pathology reports, so that they can tabulate all this information, so that, like, if you have the data in a tabular way, by the way, you will probably find a way to utilize this into your machine learning or deep learning pipelines. But if it's not tabulated enough, it's hard to build some multimodal model that you can leverage the text and the tabular at the same time without processing the text data, because it's not just text. It also has some, as I explained before, there are too much information that you can extract from that text data. So another company, Kaiser Permanente, is a hospital chain, which is also based in San Francisco, I guess. They want to forecast patient flow so that they can optimize their staff, or that like which clinical department should be busy, like will be busy on certain period of time, so that they can forecast the patient flow and optimize. If you can forecast, you can optimize, right? And Dip6 is another company that we work with for the clinical trial recruitment to find the right patient cohort given the inclusion and exclusion criteria. And DataWant is another company that are working right now. It's a very successful company working with exchanging the sensitive information between it. Because as a patient, you visit one hospital and then the other hospital and then the other hospitals, right? So how this information will be exchanged between the hospitals right now? If you identify this, how you are going to track this? You need to have some specific unique IDs per patient, right? To be able to link back the identified information, because when you de-identify, you kind of risk losing the trust, right? You may not be able to go back if you are not doing this in a right way. Like let's say you remove all the sensitive information and send this document to another hospital. And then that hospital also applied some de-identification and shared with another hospital. If they are not using of course, not using a platform that DataWant or all these healthcare analytics companies are offering their customers. In that case, you need to share some keys between the hospitals to link the records back to the patients. And then the PNNL, which is we are also working with them, with Stanford Hospital, and then PNNL, like Pacific Northwest National Laboratory, PNNL, to predict patient context, so that we can link back some symptoms to the diseases. So the first case, like MCG is, as I said, try to reduce the burden on the human coders in clinical domain. Especially human coders are still highly relevant, and it requires expertise. And then hospitals or companies try to always seek to way to reduce that burden, because it's a boring job, by the way. It's expensive and it's a boring, and then the rates are low. People do not want to do this. So which means that you need to kind of automate this process. So that's why they wanted to automate. They help the other companies to automate this process. So we work with them to build such a solution. So, or there are some radiological notes. Let's say that you want to extract and then tabulate. Let's say your job as a radiologist, or you write the reports, and then some other departments needs to extract all these key entities, so that without even open up the X-ray, the next doctor would like to see the key or the summary without reading everything, just the keywords or the summary of the reports. So we work with them to build such a solution to understand the clinical radiology, like a radiology test, the explanations coming out of with the radiology test, X-rays, let's say, and then automate this process to summarize the findings. iQuartic is try to find try to assign a risk scores to the patient as I explained like a few minutes ago. So that because the payments adjustments depends on the number of the type of the diagnosis or some risk factors. If you are prone to risk, like in the insurance domain, it's the case as well, right? So the higher the risk that you have, the rates will be higher probably. Like your insurance will be different than the others, right? So that's why you need to have that risk scores, which is unique to your case, which is going to change given your all the other attributes that you might have in your family or in your past. So that needs to be calculated before exchanging this kind of information with the stakeholders. So we basically try to automate the interpretation of electronic health records and then try to extract the patient's conditions and then assign risk factors. That's the pipeline that we build for that. So this is one of the use cases that we usually end up with. So, and as I said, usually records start with the PDF, which you might need to, you cannot say that it's not my job, or if you are working in NLP, because the extracting the data is also your job. This is true for all the other domains, by the way. Like people might have an intuition that if you are working with the large companies like Google or Microsoft, right, or big pharma companies, you will probably have someone next to you to help to get the data that you need. No, it's not the case, by the way. Even if it's a big company, there are different departments that are working on different projects that you usually probably end up doing everything that you need by yourself. Otherwise, you will be blocked by the other departments or other people, which we usually suggest newcomers or the juniors people to develop some skill sets that they will not rely on the others to accomplish their tasks. If, for example, as a data scientist, you are only developing the models, like training the models, tuning the models as a machine learning engineer, let's say, if you don't know how to extract the text from the PDF or how to query the data from some tabular or some relational data set or NoSQL data set, right? Databases, you will probably ask someone which is going to be who probably busy with some other task. So you will probably be stuck or you will blocked just because you don't know how to do this, right? That's why you not on even not on an expert level, you should be able to handle all the tasks end to end without needing any help. So yeah, that's my suggestion actually. If you know a basic level of Docker or Kubernetes or basic level of OCR and then the SQL, if you are just machine learning engineer, you also need to know all these basic steps. If you are just data analyst, you also understand how this data will be used in the rest of the process, right? So please do not expect that you will probably have someone next to you to get the data that you need. No, it's not going to happen. Or all the infrastructure will be ready 100% working. No, it's not going to happen. Everything will burn. Everything will stuck. Everything will be, you will not be able to reach the people that you need. You will not be able to find the data that you will need. And then you will probably waiting for someone else to help you, right? So that's why you should develop some skill sets to handle everything that you would need at the end of the day, because that's what matters at the end of the day, right? So with the help of some machine learning algorithms or some NLP, let's say we create some features and then these features feed some is fed to some other models. So everything is linked to each other, which you may need features from maybe as a data scientist, you also know that we sometimes develop some features coming out of from another prediction system. So like the predictions from one model will be used as a feature in the next model. So which is usually the case in the healthcare domain as well. As I said, you find the signature area. Now you rely on that area that there is some signature over here. Even knowing that signature is over there is a nice feature for you. Even you don't understand what's inside, like a date field. If there is a date field detected with my OCR model, like handwritten detection algorithm. Even if I don't understand what's inside, it's still a useful information for me because I would kind of send it to another pipeline, like handwritten extraction pipeline. Right? If I don't know, I will probably say that okay, or my algorithm will pick another date from the document. Maybe like at the footnote there is another date, and if you don't know what you are doing, you will probably pick up that wrong date, maybe the version date of the document, right? So document like in this project, I'm still talking about the iQuark project. So to how we built the pipeline, but right now I think this is a trivial information at that level because I already explained a lot. So we develop certain models because every like when you are assigned a task, it's probably you at first you approach the problem like a divide and conquer, right? Like you build module, you go module by module to end up with what they need, and then you just merge everything in a one single pipeline. And then so another thing to mention here, people like the customers or your managers will probably want to ask what's the accuracy of this model. But if this is a huge model which is comprised of multiple steps, right, you will not be able to calculate the final accuracy because every single model have its own accuracy. And then you apply some post-processing, you apply some rules, because do not think that if this is not computer vision or something, you will always need some rules to make up it's like you cannot just automate everything, and you shouldn't, by the way. There are some by the way, you should spend some time to understand if this project can be solved with machine learning or not. And then you will pray that this is not going to be solved with machine learning most of the time. Because if you are going to, if that's the only way, of course, that's what we do, right? If there is another way to do this, please go for it. Do not try to build some fancy BERT-based or deep learning-based models out there, because you will have many other issues that you may not probably envision at the end of the day. That's why if you approach the problem in a wrong angle, from a wrong angle, you will probably spend days and months to solve that problem, and then you will, at the end of the day, you will notice that you will probably find out that the same thing could be accomplished by writing the rules, because you kind of as I explained, we try to mimic the human brain, right? In machine learning, right? Like we try to abstract some, like automate some process or predict something that human being can do. But sometimes there are some rules hidden in the brain of the decision makers that if you torture further, if you explore, if you ask a lot, you will probably get that information, and then you will not even need to build any model to predict that. Because if they say that I'm using this and this and then this to find out this, so which means that if I can do the same process, then why do I need to use machine learning here, right? So which I can go back and then apply the same. I can of course use machine learning like NLP, let's say, to find that feature, because if we are going to extract the date from the documents, let's say, but there might be multiple dates on the same document. And then as a human, you know that which date to extract, because if date is next to something else, right, you may want to extract that date precisely if there are multiple dates on that document. Since human coder knows this, if I ask that guy how you pick the right date, he would probably say that, okay, I check the dates. If I see that term right next to the date, and if it's later than the date B, I select that date. So which means that right now I use machine learning to find the dates, all the target dates. Now I use that rules that I just got from the human on the field, let's say. And then I apply that rule. I just code it up, and then I sort the dates and then check the neighboring words, and then I extract the right words. Now I use machine learning and rules, which is the perfect representation of the reality, actually. Okay, so let's skip these parts. And then, by the way, I already covered many of the case studies at the first slide that I said. Like I tried to explain what each company does, right? Right now, these are all the details. So I probably want to keep this short by just getting into the lessons learned part, right? So like MedStream is another company that are trying to automate the medical code extraction process for their own customers. So they have their own platform that we work together to make this platform successful, right? So, which is another things to mention right now. So, right, sometimes the models that you build is going to be a part of another small solution that is also part of another small solution. So these are all linked to each other, and then the error propagates. If you have some errors here, it's going to be propagate to the other model and then the other model. So you try to see the big picture as much as you can. Otherwise, if you just focus on the task that you are given, if you don't understand the consequences that you probably overlook, because you sometimes try to make it happen and then you just overlook something and you just treat it as an outlier. But that outlier might lead to many other issues in the other platform or in the other model that your model will feed the input, right? So, and there are some granular details that we did, like there are tons of approaches that's why you need to read. You need to read how other people solve this problem. If you just trust your gut feeling, if you just trust your judgment, you will probably not be able to leverage all the other experiences, because there is no way that we get this experience by working on a million different projects, right? No, that's why right now you are listening to me, right? So right now I am exchanging some stories that I had before, and then you kind of adopt, or maybe you will probably remember in the future while you are working on some projects similar to what I am explaining here, right? That's why if you can read the memories, like some memoirs that people share, some lessons learned, or some, even if you don't want to read the academic papers, even if you read some Medium articles, you will probably find many useful information out there. You don't need to code it up physically, right? But if you understand what kind of problem they had and how do they solve it, you will probably your brain will not be same after you read something, right? Everything will rewired in your brain. So there are some lessons learned from this model. So there are usually more than one models that could help you to find the right correct prediction. So you need to assemble the models probably, because if you try to patch, this is another pitfall, by the way. Sometimes people try to rely on the pre-trained model too much, that they apply some patching, like they just patch. So if this is a wrong prediction, they change something to make it happen. They add regex, and then they add another model, and then they try to build some Frankenstein, we call it. So which means that it's a combination of hundreds of different models or rules or regex that somehow works, but hard to maintain, right? So instead of doing this, we always suggest train your own model by using the pre-trained models like some transfer learning, etc. If this is not possible, which means that you need to assemble the different models as simple as possible, not make it more complicated that it needs to be, okay? And in terms of NLP, everything's like error propagates. Like if you cannot detect the sentences correctly, if you cannot split the sentences correctly, it's going to impact the next model. Like a sentence detection is one deep learning model. Name identity recognition is another deep learning model. Relation extraction is another deep learning model, right? These are all different models that's why we build this kind of like Spark NLP or Hugging Face or Spice. They all try to solve this kind of like in one single pipeline. So, which means that if you fail at one step, the error in the second step, you will never know if it's coming from that second model or the model that is failed at the first step, right? So if you are using multiple deep learning models, and if you are experiencing some issues, observing some errors, do not blame that model, because that error might come from the previous model. And in the healthcare domain, fun effect is most of the time, half of the errors comes from the human. So like a ground truth errors. So we usually, for example, in our annotation projects, so we, for example, and have like a multiple physicians, like medical doctors, annotate the text, and then after a few weeks, they somehow agree each other, because when it comes to medical domain, every doctor has different perception in their mind, that one of them say A, the other will probably say B. That's why it's kind of easy to automate this process, because you just need to generalize between their decision process. Anyway, so most of the times we get predictions from the model, and then the next week they end up with their own predictions. While annotating the data, they start with soft labels, not from scratch. That soft label comes from the average of their previous annotations, which we train a model. That's why the next time they see that, they kind of fix themselves. And then we also get some predictions from the ground truths, which the model already saw, which is another nice experiment, by the way. Like, we train the model with the data set, they annotate it. So the model saw entire data set, let's say, and then we get predictions from the same data set, from the same train set. When you do this, if the model fails on certain entities, certain data points, which means that the data points might be wrong. Because if the model, because the job of deep learning, like machine learning, is to generalize, right? Right, generalize, because noise, there is a noise in the data, right? So noise means that sometimes when you make a decision, by the way, Daniel Kahneman, like that, Think Fast and Slow, right? That the author of that book. So is another book, like a noise. Like, there is a noise in your decision-making process. That's the beauty of machine learning models, by the way, because in machine learning, the job of machine learning models is to get rid of that noise. Like, assume that you are doing some regression analysis, right? So there are some dots, right? So your perfect line, you don't want to overfit, you don't want to underfit, right? You want to generalize, which means that you want to get rid of the noise in your data. So in that case, machine learning models, especially in the medical domain, is very good at getting rid of the noise to find the average of the multiple decision maker, like a human physicians, right? So if model fails generalizing, even on the data points it memorized, because when you train further, it will memorize it, which means that there's an error in the ground truth, because the errors usually happen rarely, right? Human error, which means that annotation is also wrong. So we ask them, think again, like, which one is wrong, like you or model, which one? So we usually say that like half of the time model fixes the human error. Anyway, so that's why you also suspect your human annotators. Okay, so let's skip this kind of projects. I think I talk a lot, because the concept is always same, right? You have the record sitting somewhere. In the other domains, you have some records, of course, sitting on some relational database or unstructured databases, or some documents, physical documents, right? So your job is to offload that data in NLP. You offload that data with like OCR. If it's just a text data, you don't even need the OCR, right? You just offload the data and then feed it into your pipeline to apply all the steps that I have been trying to explain so far. So we create a pipeline composed by some modules, and then that pipelines run in a cluster or some IT infrastructure, and then you want to scale. So while you are building the model, building the pipeline, you should always envision the last point, like when you deploy this, because let alone the accuracy, Of course, the accuracy might not be same on the production set, but another important point is that like this might be working fine, but if you want to scale this further, right now you are working on 1 million documents, right? Say, but in production, it's going to process 10 million documents every day. If it's going to do well in the same, that while you are developing, so that's you always develop like work in a way that's going to be scaled easily when you deploy this. Otherwise, the people who try to maintain this, sometimes we spend tons of boring hours just to maintain the models, just to make them run or scale. That's why the tech stack, that like the language, that the algorithm, that the framework that you use while building your model should be selected in a way that they can work well in production as well. Okay, that's why you need to select your tools very well. Otherwise, if you want to, let's say that you don't have cloud services, you want to do this on-prem everything, like which is usually the case in the healthcare domain. In that case, if you don't get to use any cluster environment, if you don't have a cluster, why do you use Spark, right? Or if you have a cluster, why not? Why not use Spark rather than using some libraries like Pandas, right? If you use this, you will not be able to leverage the distributed processing, etc. Okay, so what else? Yeah, I think I covered most of the use cases, so I can keep going. But this is I have 100 slides actually, so I can cover all one by one, but no need to do this. Let's do some Q&A. If you guys want to know further, like other than what I explain, I try to explain so far, what kind of trends I am seeing in the industry, or what kind of headaches am I having lately. So we can have some short Q&A session if you guys want. Murat? I think I can take some questions, or let me stop sharing and then I will try to read questions if there is any. I see only one question, which asks like, is Spark the popular tool in industry to make the pipeline? Like the beauty of Spark NLP is that you don't need to get out of the same pipeline to transfer your data. And if you want to scale your model at the end of the day, as I explained, you may want to use a pipeline concept like a framework like Spark NLP, so that you don't need to import any other library. And in the healthcare healthcare industry, it's very hard to. Yeah, it's another fun fact, by the way. We usually work with like a high compliance environments that you cannot easily pip install, because when you log in to their platform through VPN, when you are working with the sensitive data, you usually do not have an internet connection, or you shouldn't have a live connection if you are working with the sensitive data. So you should definitely handle everything offline. That's why the library, that the tech stack that you use should be working offline without any other dependencies. So if you like somehow, it's a usual practice in data science that we usually jump from one library to another, right? Like we import one library and then pip install another one and then the pip install. So if you don't know, if you are not well experienced, when you are like locked out, right? When you log into their environment and don't have an internet connection, so you are stuck right now. You cannot install anything. So which means that you will just back that IT guys, like a system admins, that okay, I need that library, please install that for me, etc. So that's why you need to select some libraries or modules or frameworks that wouldn't require any additional dependencies that would block you in the middle of the project. Spark NLP, in terms of Spark NLP, for the last 3 years, there are some industry surveys in the healthcare domain that it's the most popular NLP library in healthcare industry, which is also leveraging the transformer architecture, etc. Which you don't need to install any any other libraries. And it can be supported by Scala, Java, R, and Python. So another question. So what am I doing? Like, as I said, at Johnson Knowles, so we have several teams. Like healthcare, we are mostly working with the healthcare projects. We have our own software and libraries like Spark OCR, Spark NLP, open source Spark NLP for healthcare licensed one. I am the one leading the healthcare side, by the way. So, and we have an annotation lab. So we are working on our own products as well as serving the customers, as well as taking care of our own people to train them on the new model. We are releasing every 2 weeks to sync well with the latest development in the deep learning architectures and the research. And we also publish some papers. Okay. Another question, could you please explain the specific text in the maintenance of ML models? So maintenance of ML models, so if you are not using some full-fledged MLOps platforms, right, you probably end up developing your own solutions to maintain your own models. So if, let's say that in terms of NLP, let's say that you work on a project to develop some prediction model to extract the entities and link everything, and then link everything together. 6 months project. Now you deploy this, it's working fine. And after a few months or few years, you will probably end up like seeing some drift, which is not going to do well as much as it used to do, because some things might change in the future. And then you probably need to retrain your model with the new data. So what we usually do, like we usually like the projects that we run, in terms of that, the projects that we help with the other companies to do, they usually maintain with our help. So at some person, if this is not online learning or active learning, they usually at certain point of time manually train if they are not using MLOps platforms. Or what we do at Johnson Knowles, for example, like because we have tons of pre-trained models, right? So what we do is at every specified period of time, we get predictions on some latest, like from the same domain. Let's say if this is trained on a PubMed data set, if this is trained on some clinical modes. So we try to get some real representation of the same data set, and then try to get some prediction if the model still holds true, right? Then we add some new data points to expand the model and then retrain. This is one way of doing this. Or reshuffle everything so that it just doesn't learn from the latest data points, but the entire. So if you are lucky, but you should be, by the way, you should automate this process that you like in one of the projects, what I did is, by the way, I deployed the model. It was serving behind an API. Then every Sunday morning, let's say, I put the new data sets, new data points from their structural data point database, retrain the model, and then evaluate the metrics, and then try to replace the previous model or not. Sometimes even the accuracy is low, by the way, given the compared to previous model, because when you have the new data points, right, you will probably have new data, new test set as well. And even the accuracy would be lower than the previous one, you may want to select the new one. Even the accuracy is not better than the previous, because right now you are using another test set. So it doesn't mean that it's doing better. It's doing worse than the previous one, right? So because it might be more generalizable with less accuracy. So you would be fine with that loss, even if it's generalized further well enough. Okay. So another one is, can you talk a little bit about the work necessary to deploy Spark NLP pipelines as an API? Okay, perfect topic actually. We use this every day. So in Spark, it's living JVM, right? So it's another issue that I skipped, by the way, because we don't need to talk about how Scala or Spark works. But when you want to deploy this, if this is not a batch processing, if you are just going to get a live predictions given your text data, let's say, You just need one server, right? Let's say one instance. You don't need a cluster. In that case, what you may want to do is, what we do is we use like pipelines over there, which means that like pipelines is the pipeline concept introduced by Spark NLP to Spark community by pulling everything into single machine instead of trying to distribute. Because if you are using distributed frameworks like Spark, but you are processing small data, you will get some latency that you wouldn't get with some simple libraries like Pandas or Spicy, right? Because you are designed something, it's like a locomotive racing a bike. So the bike will be faster at first, of course, given the locomotive, inertia, right? But when the load gets higher, like the data set size gets higher, locomotive will be fast, like the locomotive will beat bicycle, right? If they compete each other. So which means that if you are using small data, you don't need to, you may not want to use Spark, but if you still want to use Spark because it's an end-to-end pipeline, because you may want to experiment with the small data but process large amount of data. So what we did is we developed light pipeline to deploy our models behind some REST APIs without dealing with communication between the workers. So that's why we deploy our models by caching at first and then deploy with the light pipelines, so it doesn't need to deal with the overhead of Spark itself, like overhead of distributed computing itself. It doesn't need to distribute the data that I sent to that API to the other cluster, so it will just work on a single core, like a single machine. And then in that case, so it's right now as fast as any other non-Spark solutions. So that's what we use to deploy our models with Spark NLP by using light pipeline, building the pipelines on the fly. And for example, sometimes I apply some tricks that I load all these models, pre-trained models into cache, and then assign to as a key value pair in a dictionary. And then I build the pipelines on the fly if user wants to experiment with different combination of the pipelines, different combination of the models, because building the pipeline is another time-consuming steps if you want to keep, because that like a combination would be endless, right? Okay. Any other question?
Kocaman, I am covering for Murat. Actually, we have a couple of more questions in the Q&A. If you would like to answer them as well.
So in the Q&A, I only see the chat. Okay, I saw. Okay, I got it. I see two questions. For non-coders who specialize in text mining, what would you recommend in terms of software? Okay, so you would like to use some like a package without coding. There are some AutoML solutions, like, or some MLOps platform like a Data Robot or Data EQ or this kind of what. These are all commercial solutions, I guess. There are some when it comes to text mining. I know that there are rapid miners I kind of used in the past, but I'm not very well versed to answer this kind of questions, maybe because right now I do everything with coding. But for the non-coders, you can hire someone and then help you because it's very customized. But I don't want to disrespect, but I just want to say, since I don't use any package without coding in text mining, I will probably fail to answer this question. But I would probably Google it right now, but right now I am not able to answer this question, sorry.
Actually,
there might be probably.
Oh, sorry for interrupting, Dr. Kocaman. Once in a while, we have NLP courses for non-coders. Although I am not specialized in that area myself either. I am a coder myself too. But we can refer you, Jimmy, if you like, to this series. We have an NLP for non-coders classes once in a while.
Yeah, probably there might be many cool tools out there that let people, because like this is another thing that I want to mention. Sometimes it's almost impossible to hire or keep that skill set into your company if you want to experiment with something, right? So that's why people try to outsource or try to build this kind of tools that the startups are working on, right? Or some companies are like, or some cloud providers are offering. So, okay, Microsoft Azure and GCP and AWS have some APIs that you just make a request, you just upload your text, and it returns the prediction. For example, for the clinical one, Microsoft has, AWS has AWS Medical Comprehend that you just upload your text, and then you get predictions with some clinical entities, relations, etc. Which we wrote some paper, by the way, about that how we beat their benchmarks. Another one is GCP, like Google Cloud, right? Google Cloud Platform also has some NLP APIs. So the easiest solution for this question, like the easiest answer for this question would be using some cloud providers predefined, like pre-trained models that you just upload your text via API or no code at all. You just want to experiment. You can just upload your text with these two APIs. By the way, that connecting these APIs to your own software is an easy task if you have even a front-end developer, right? Then you can experiment with the state-of-the-art technologies from Google or AWS or Microsoft. So this could be a perfect example. So another question, do you have any knowledge about the usage of machine learning in energy industry? Is there also a project dedicated to create algorithms to predict energy consumption in future? I'm also in Netherlands participating in a project to reduce energy costs, like the owner of the question says. So in my PhD, I also work on energy projects. Like one of the paper that I'm working on right now is how to detect the anomalies on the solar panels. There are some drone images and videos that we process and then try to find out which kind of anomalies cause which kind of reduction in the energy efficiency or negatively impact the costs. So in that case, like we use computer vision, of course. But I think your question is not related to this computer vision versus detecting the anomalies on the solar panels, but the energy consumption in the future. So since everything is digitized right now, it's probably an easy task to collect these data from IoT devices, which I didn't work, by the way, but which would probably be, I kind of, while working on my paper in that PhD, I kind of saw some researchers that are trying to predict the energy consumption. By the way, for example, in Netherlands, since we are also living in Netherlands, we pay in advance, like for these kind of bills and the electricity and the water bills. So what we do is, I kind of had some ideas before about this. What if because there's a free market here that every company try to pitch their product, right? So they say that, okay, if you pay like 200 euros per month and you are not going to get a surprise at the end of the year, etc. So how do they do this? They predict, given your neighborhood, given the season, etc., your consumption. Otherwise, at the end of the year, you will get additional bill as a consumer, and then you will probably feel cheated, right? Because you don't want to pay more than you are promised to do, right? So that's why those companies are right now using this kind of algorithms, this kind of solutions to predict the energy consumptions, given your family type, given even your race, by the way, because the race also matters for the energy consumption. So like the neighborhood or the street, even the number of the houses on the same street. These are all the nice features that you need to talk to some domain experts if you are going to work on this kind of projects, because you will definitely stuck and hit the wall if you just start coding from scratch. Another question from Jimmy is, what do you see as the future of NLP in healthcare industry? Are there any groundbreaking concept processes that have come out recently? So not in NLP, but like OpenAI just released that protein folding, etc. This is the coolest thing, by the way, for the last few years. That if you can kind of understand how the proteins folds correctly, you can find why sometimes they don't fold correctly, and then some anomalies happen. This is the video of, as I explained before, extracting some patterns that are hard to find by a human being, which are sometimes like endless combinations. So in terms of NLP, right now, pre-trained models, like a bird family, especially in the clinical domain, as it's the case in every other NLP domain, by the way, right now it's shaking everywhere. Everyone is trying to, especially GPT-3-like models like GPT-J, GPT, like a light version and the free version of the GPT-3 is also available right now that you can easily plug and play. For example, if you are trying to leverage NLP, but you don't have enough skill set, you can just get like subscribe these kind of APIs, which are just providing plug and play solutions. If you just have one IT guy in your team who have no idea about machine learning, you can just subscribe these kind of APIs to get live predictions, which might be another answer to your first question, by the way, Jimmy. For the latest breakthrough in NLP healthcare, we are mostly working on right now hierarchical learning concepts, not just learning from one single document, but multimodal approaches, not just NLP, but also getting benefits from the computer vision, some OCR technologies. Also, for example, to classify the documents, sometimes, surprisingly, sometimes that ResNet VGG architectures that are just trained on cats and dogs, right, are also doing well. Yeah, because as a human, when you look at the document, you get some sense of the type of the document, right? That's why, like the multimodal models are architectures are hype. And another cool thing would be in terms of healthcare NLP is that we are using representation of the text, right? Like vectors, like word embeddings, bird embeddings, etc. So and attention mechanism, like that is powering all the bird architectures transformers. So sometimes right now we are trying to use the same, not we are, but the community, like the research community, try to use the same approach to find the sequences in the DNA or in the proteins, so that they would be able to understand the reasons behind some metabolic actions in your body, etc. Okay, I think I answered a lot. So you can reach out to me with my LinkedIn, like if you just Google my name, like Veysel Kocaman, and you will be able to find me on LinkedIn and then reach out to me. My email is also veysel@johnsonlabs.com. You can also just Google me and you will find my email and my profile as well. I'm open to connect everyone. And then so far I never ignored any messages, probably.
Great. Dr. Kocaman, it was great having you as a speaker for our
Thank you.
Industry Insight series. A very nice and thorough demonstration of NLP concepts applied to healthcare industry with use cases, customer case studies, some of the best practices and lessons learned. And Q&A session was really great. I enjoyed it so much. Thank you for the wonderful speech. I personally am looking forward to hearing more about your work in NLP in the future and the rest of your 100 slides. Thank you so much. It was great. For our listeners, if you would like to have a talk on a data science related subject, please write to us, email us at info@magnemindacademy.com and tell us what you have in mind with a brief biography. And we would like to, we would be happy to host you as well. Until our next meetup, have a wonderful day, everyone. Thank you, Dr. Kocaman, one more time.
Thank you, everyone. Thank you. Have a nice weekend. Bye-bye.